Looking around today, twin-engine jets dominate the skies alongside the occasional four-engine jumbo, while the Trijet has completely disappeared. What forces destroyed a setup that many aviation specialists viewed as the ideal design? Was the cause regulatory, technological, or economic? Today, we explore the captivating history behind the rise and subsequent decline of the Trijet, the forgotten middle child of aviation. Picture the year 1968. Commercial flight is thriving, but a major obstacle remains. To transport passengers across oceans, aviation regulators require backup safety systems in the form of extra engines. Consequently, airplanes like the Boeing 707 required 4 engines, turning them into fuel-guzzling machines. Boeing provided the initial solution with the 727, which featured a distinctive tail design that built the third engine right into the vertical stabilizer. This specific layout enabled flights out of short runways and high-altitude airports that bigger jets were unable to use. Rather than just being successful, the 727 proved to be revolutionary. It was adopted by airlines across the globe, resulting in Boeing selling 1,832 units, an incredible figure for that time period. However, the genuine Trijet revolution was only starting. For long-distance routes, the competition centered on 2 giants: the McDonnell Douglas DC-10 and the Lockheed L-1011 TriStar. Coming to market in the early 1970s, both promised to transport travelers over oceans with an ideal mix of safety, distance capability, and efficiency. If you have ever questioned why these 2 airplanes debuted at the exact same time, it was not just a fluke. American Airlines was instrumental in creating the market demand for them. The carrier wanted a downsized, cheaper alternative to the massive Boeing 747 that could still travel long distances effectively with a large passenger load. To satisfy American Airlines and rival carriers, both McDonnell Douglas and Lockheed created their respective 3-engine models, the DC-10 and L-1011, shifting the course of aviation history. The early triumph of the Trijet relied on regulatory strategy just as much as smart engineering. The FAA maintained a policy known to pilots as the 60-minute rule, which restricted twin-engine planes to routes that kept them within an hour of an emergency airfield. Traveling over an ocean with only 2 engines was out of the question. This regulation carved out an ideal market position for Trijets, which were cheaper to run than 4-engine planes, but completely free from the restrictions slowing down twin-engine models. By utilizing a third engine, airlines could chart direct paths over the Atlantic, Pacific, or polar regions, serving highly profitable markets while using less fuel than 4-engine jets. The L-1011 earned a reputation as the Rolls-Royce of the skies, boasting cutting-edge avionics, superb flight handling, and the sector's very first auto-land system approved for Category 3C approaches, which permitted landings in zero-visibility conditions. Meanwhile, the DC-10 provided an adaptable platform that appealed to airlines, offering different versions tailored for specific flight profiles, ranging from high-capacity domestic hops to extreme long-range global routes. Both models stood out as engineering triumphs that propelled the entire industry forward. But their greatest innovation, that third engine, would ultimately lead to their downfall. If there is one acronym that sealed the fate of the Trijet, it is ETOPS, Extended Range Twin-Engine Operational Performance Standards. This framework represents perhaps the most significant regulatory shift in commercial aviation history. It raised a pivotal question. What if twin-engine aircraft became so reliable that they no longer needed to stay within an hour of diversion airports? By the early 1980s, engine reliability had improved dramatically. The operational time between failures had increased exponentially, prompting aviation authorities to reconsider their stance. In 1985, the FAA granted the first ETOPS 120 approval, allowing properly equipped twin-engine jets to fly routes up to 120 minutes from the nearest suitable airport. By 1988, ETOPS 180 became a reality. The impact was immediate and devastating for Trijets. Suddenly, aircraft like the Boeing 767 and Airbus A310 could fly almost any route a Trijet could, while burning less fuel and requiring less maintenance. The third engine, once a regulatory necessity, had transformed into an expensive redundancy. As one veteran pilot put it, it wasn't that 3 engines were bad, but rather that 2 engines got so much better. Consider this fact: a single modern GE9X engine produces more thrust, 134,300 pounds force, than all 3 engines on a DC-1030 combined, approximately 125,100 pounds force. That is not just an incremental improvement, it is a revolution. As ETOPS ratings extended even further, eventually reaching up to 370 minutes, twin-engine aircraft gained the ability to fly anywhere on the planet, rendering the Trijet concept obsolete. While the third engine seemed elegant on paper, in practice it created complex engineering challenges. Most obviously, placing a massive turbofan in the tail is complicated. The L1011's design team faced the vexing problem of how to feed air to an engine embedded in the vertical stabilizer. Their solution was an S-duct that curved through the tail to feed clean air to the number 2 engine. This engineering marvel came with high costs, adding weight, complexity, and maintenance challenges. Every pound of additional structure reduced payload capacity and increased fuel burn. The DC-10 mounted its tail engine higher on the fuselage with a straight-through inlet. While simpler, this layout created its own issues, including potential pitch instability. Maintenance was perhaps the biggest headache of all. Technicians had to work on an engine suspended roughly 30 feet above the ground. Tasks that were straightforward on wing-mounted engines became logistical nightmares. One technician recalled needing specialized equipment just to reach the tail assembly, noting that engine changes taking hours on a wing could take days in the tail. This complexity carried serious implications. On May 25, 1979, American Airlines Flight 191, a DC-10, lost its left engine after takeoff from Chicago O'Hare. The engine separation severed hydraulic lines and caused the wing slats to retract. The resulting crash killed all 271 people on board and 2 on the ground, making it, at the time, the deadliest accident in US aviation history. While the disaster actually stemmed from improper maintenance procedures rather than inherent design flaws, it highlighted the severe consequences of mechanical complexity. Airlines increasingly began to ask, why deal with the complexity of 3 engines when 2 can do the job? By the 1990s, the airline industry was rapidly transforming. Deregulation had intensified competition, fuel prices were volatile, and profit margins were razor-thin. Efficiency was no longer just desirable, it was a matter of survival. Because a Boeing 767-300ER burns less fuel per hour than a DC-1030, the difference over an aircraft's operational lifetime can represent tens of millions of dollars in savings. The math became unavoidable. McDonnell Douglas recognized this changing landscape and developed the MD-11, an advanced evolution of the DC-10, featuring winglets, a stretched fuselage, and more efficient engines. However, the MD-11 faced a perfect storm. It arrived just as ETOPS-approved twin jets were proving their reliability, and worse, the aircraft failed to meet its own performance guarantees. As a result, just 200 MD-11s were built before production ended in 2000. Airlines that had built their long-haul fleets around Trijets faced difficult decisions. Carriers like British Airways, Singapore Airlines, and others began replacing their DC-10s and L1011s with Boeing 767s and 777s. Even cargo carriers, who had previously embraced Trijets for their capacity, eventually surrendered to economics. FedEx, once the world's largest operator of DC-10s and MD-11s, began phasing them out in favor of twin-engine freighters that offered more payload with less fuel. "The MD-11 is a workhorse," admitted one FedEx fleet manager. but it's just not as cost-effective in the long run. There is also a fascinating psychological dimension to the Trijet story that is often overlooked. For decades, passengers associated engine count with safety. More engines meant more redundancy, a compelling logic that helped market four-engine aircraft like the 747 as the ultimate in safety. When Trijets emerged, they benefited from this perception. 3 engines simply seemed safer than 2, and the aviation industry did little to discourage this belief. But was it actually true? The data tells a different story. Modern twin-engine aircraft have achieved remarkable reliability, to the point where the probability of a dual-engine failure on a twinjet is actually lower than the probability of losing 2 engines on a trijet. A Boeing 777 can operate for over 100,000 hours without a single in-flight shutdown, making the odds of both engines failing simultaneously astronomically low. "I still hear it from passengers," said one captain who transitioned from the L1011 to the 777. "They look at these 2 huge engines and ask, what happens if they both fail? I tell them that's like worrying about being struck by lightning while winning the lottery." Yet, this psychological barrier took years to fully overcome. But as twin-engine aircraft began routinely flying 15-plus-hour routes over remote regions, perception shifted. By the mid-2000s, this psychological barrier had entirely eroded. Passengers cared far more about modern interiors, entertainment systems, and onboard service than they did about engine count. Today, passenger-carrying Trijets have all but disappeared. The last scheduled passenger MD-11 flight, operated by KLM, touched down in 2014, marking the official end of an era. While a handful still fly cargo routes, others serve specialized roles in aerial firefighting or as flying test beds. The vast majority, however, have found their final resting places in aircraft boneyards across the desert Southwest. Walk through the Mojave Air and Spaceport or visit the Pima Air and Space Museum and you will find rows of DC-10s and L1011s, their paint slowly fading under the relentless desert sun. The pilots who flew them still speak with absolute reverence. "The L1011 was the most forgiving, smoothest handling widebody I ever flew," recalled one retired captain. Modern aircraft are more efficient, but they don't have the same soul. The Trijet era lasted barely 4 decades. Though a brief chapter in aviation history, it left an indelible mark. Perhaps its most important legacy is what it taught the industry. The balance between redundancy and efficiency is never static. As technology advances, that equilibrium shifts, and what made perfect sense in one era quickly becomes obsolete in the next. So, why did Trijets disappear? It wasn't caused by any single factor, but rather a perfect confluence of regulatory changes, technological breakthroughs, economic pressures, and evolving passenger perceptions. The Trijet solved a highly specific problem at a specific moment in time: how to fly long distances efficiently when regulations strictly restricted twin-engine operations. Once ETOPS eliminated that problem, the operational rationale for a third engine vanished with it. Could Trijets ever make a comeback? It is highly unlikely. 2 massive, ultra-reliable engines are simply far more efficient than 3 smaller ones. The physics and economics remain unyielding. Yet there is something undeniably special about these aircraft. Their distinctive silhouettes, with that third engine nestled uniquely in the tail, represent a fascinating period when aviation engineers refused to accept limitations and found an elegant compromise that opened up new global possibilities. The next time you board a twin-engine Boeing 787 or Airbus A350 for a 15-hour flight across an ocean, remember this: your journey was made possible, in part, by the Trijets that came before them. They were aircraft that pushed boundaries, challenged assumptions, and helped create the deeply connected world we take for granted today. They may be gone from our skies, but their legacy flies on with every long-haul flight crossing the globe. Did you ever fly on a Trijet? Share your experiences in the comments below. And if you're fascinated by aviation's evolutionary dead ends and forgotten marvels, hit subscribe and the notification bell for our next deep dive into aviation history. Until then, keep looking up.